Welcome to EDU World Space.
The relative velocity of the stream relative to the blades can be written as in the form of equation u is equal to v times v. Okay, now the mass flow rate is delta m upon delta t is equal to rho a v a, or you can say that velocity at point A. Okay, now applying the impulse and momentum principle, we can write this represents the direction, positive direction, positive horizontal direction. So delta mu minus ft delta t is equal to delta mu cos theta. This equation represents the impulse momentum equation or impulse momentum principle. Okay, let's move further. Here we are going to simplify this equation and rewrite this in the form of f of t into delta t will be is equal to delta mu minus delta mu cos theta is equal to, here we are taking the delta m of u common, so I will have 1 minus cos theta. Okay, now in the next step we are going to simplify this equation further. So f of t will be, I am taking this delta t in the denominator of right hand side part, so delta m upon delta t, which will be nothing but my mass rate, u 1 minus cos theta. Okay, but as we know, the mass rate equation will be rho into a into va. So let's write, instead of dm upon dt, that will be rho area a, rho is the density, and va is the velocity at point A, times va minus v. Here instead of u, I have written va minus v. That comes from our very first equation, that u is equal to v into v. Okay, and the remaining term 1 minus cos theta. Okay, now referring to the figure 1, this figure, the tangential force on the fluid is to the left. Then the tangential force on the blade is to the right. Okay, so my output power will be P output will be is equal to F of t times V. Okay, now let's simplify this equation further. As we know, the formula for the F of t in the above equation, this one. So I'm going to put this F of t in the output power formula. So finally I will have rho times A VA VA minus V times V 1 minus cos theta. Here I'm going to multiply this V into the bracket, this bracket. So I can write rho A V1, sorry, rho A VA times VAV minus V square into 1 minus cos theta. Now the velocity for maximum output power can be calculated as dP output upon dV is equal to, so we are taking the derivation of this equation with respect to velocity v. So I will have rho A VA the VA, because dV upon dV will be 1 minus 2V, the derivation of V square will be 2V into 1 minus cos theta is equal to nothing but 0. Okay, so let's move further. So I can rewrite this equation as VA minus 2V will be 0. Therefore, my V will be 1 half of VA. Moving further, to find out the maximum power, I can write P output max is equal to rho A VA VA minus 1 half VA into 1 minus cos theta. Let's simplify this one. So I will get 1 by 4 rho A VA cube 1 minus cos theta. Now the input power is the rate of supply of kinetic energy to the stream. So I can write the input power as P in is equal to 1 upon delta T times 1 half delta m VA square. By simplifying this one, I will get the final answer as 1 half rho A VA cube. What I have done to simplify this one, simply I have taken this delta T with delta M. So that will give me the mass rate delta M upon delta T, and we know the formula for the mass rate is nothing but rho AV, and V into V square will be my V cube. So that's why I'm having rho AV cube here in this equation. And lastly, to calculate the efficiency, I can write efficiency eta M is equal to ratio of two powers, or ratio of output power to the input power. So let's divide both the powers to get the efficiency, or simply we can divide both the equation. The equation this one is for input power, and equation for the output power is here. Okay, so my output power, the ratio of output power and the input power, please make correction. Here we are taking the ratio of two powers, output power and input power. So my output power is this one, and my input power is this one. So we are taking the ratio of these two to get the efficiency, and by taking the ratio I will have the final answer 2 times 1 minus V upon VA into V upon VA times 1 minus cos theta. That is my efficiency eta.